Hello everyone. Good day. This time we will talk about high voltage electrical lines. Electric power transmission is the bulk movement of electrical energy from a generating site, such as a power plant, to an electrical substation. The interconnected lines which facilitate this movement are known as a transmission network. This is distinct from the local wiring between high voltage substations and customers, which is typically referred to as electric power distribution. The combined transmission and distribution network is part of electricity delivery, known as the electrical grid. Efficient long-distance transmission of electric power requires high voltages. This reduces the losses produced by heavy current. Transmission lines mostly use high voltage AC, alternating current, but an important class of transmission line uses high voltage direct current. The voltage level is changed with transformers, stepping up the voltage for transmission, then reducing voltage for local distribution and then used by customers. A wide area synchronous grid, also known as an interconnection in North America, directly connects many generators delivering AC power with the same relative frequency to many consumers. For example, there are 4 major interconnections in North America: the Western Interconnection, the Eastern Interconnection, the Quebec Interconnection and the Electric Reliability Council of Texas, ERCOT, grid. In Europe, one large grid connects most of continental Europe. High voltage transmission lines deliver electricity over long distances. The high voltage is required to reduce the amount of energy lost during the distance. Unlike other energy sources such as natural gas, electricity can't be stored when it is not used. If demand exceeds supply, a blackout occurs. A comprehensive national grid with many redundancies has been built to mitigate these circumstances, and overhead high voltage electrical lines can frequently be encountered by farmer, construction workers, and local residents. Because overhead transmission lines are not covered by insulation, there are many safety considerations when working and playing nearby. Historically, transmission and distribution lines were often owned by the same company, but starting in the 1990s, many countries have liberalized the regulation of the electricity market in ways that have led to the separation of the electricity transmission business from the distribution business. Equipment needs to maintain proper grounding to avoid a shock hazard. If a piece of equipment comes into contact with high voltage lines and is not properly grounded, anyone touching this equipment could get shocked. Maintaining proper grounding reduces the risk of shock. A number of factors play into the severity of shock, such as the voltage, distance from the conductor, the size of the objects, and its distance from the ground. The benefits of high voltage electrical lines are to deliver electricity from power generation centers to load centers that are very far away. With the high voltage electrical lines, the distribution of electricity becomes more efficient. High voltage transmission lines are a critical part of the energy infrastructure we depend on. They are installed and maintained by skilled professionals, and they demand respect because of the energy they carry. The energy grid we depend on is so reliable, we often take it for granted. Next time you flip a switch and turn on a light, think about the work that went into making that simple act possible. And how in years past, nearly all human activities stopped after sundown. Things we take for granted are a crucial part of our modern society. We appreciate the hard work and professionalism that goes into maintaining this crucial part of our lives. High voltage overhead conductors are not covered by insulation. The conductor material is nearly always an aluminum alloy, made into several strands and possibly reinforced with steel strands. Copper was sometimes used for overhead transmission, but aluminum is lighter, yields only marginally reduced performance and costs much less. Overhead conductors are a commodity supplied by several companies worldwide. Improved conductor material and shapes are regularly used to allow increased capacity and modernized transmission circuits. Conductor sizes range from 12 square millimeters, number 6 American wire gauge, to 750 square millimeters, 1,590,000 circular mils area, with varying resistance and current carrying capacity. For large conductors, more than a few centimeters in diameter, at power frequency, much of the current flow is concentrated near the surface due to the skin effect. The center part of the conductor carries little current, but contributes weight and cost to the conductor. Because of this current limitation, multiple parallel cables, called bundle conductors, are used when higher capacity is needed. Bundle conductors are also used at high voltages to reduce energy loss caused by corona discharge. Today, transmission level voltages are usually considered to be 110 kV and above. Lower voltages, such as 66 kV and 33 kV, are usually considered sub-transmission voltages, but are occasionally used on long lines with light loads. Voltages less than 33 kV are usually used for distribution. Voltages above 765 kV are considered extra high voltage and require different designs compared to equipment used at lower voltages. Since overhead transmission wires depend on air for insulation, the design of these lines requires minimum clearances to be observed to maintain safety. Adverse weather conditions, such as high winds and low temperatures, can lead to power outages. Wind speeds as low as 23 knots, 43 km per hour, can permit conductors to encroach operating clearances, resulting in a flashover and loss of supply. Oscillatory motion of the physical line can be termed conductor gallop or flutter depending on the frequency and amplitude of oscillation. That's all about the video this time. Thanks for watching Channel Secret Paradise. See you.